Let's now take a look at the three primary vendors that own graphics kernels and compare how they either kept them in-house or commercialized them. PTC revolutionizes CAD with parametric modeling. PTC Creo Screenshot. PTC Creo Screenshot. Parametric Technology Corporation, PTC, developed its proprietary geometry engine headed by Leonid Reyes, later one of the creators of Revit, to power its Pro/Engineer, now Creo, software, aiming for a robust, in-house solution to support parametric and history-based modeling. It was the world's first fully parametric geometry engine and was an instant success. They ran on Unix workstations and later Windows PCs, but offered an unprecedented level of flexibility in modeling that changed the ways many products were designed outside the traditional aerospace and defense and automotive niches where PLM had been confined prior to this. PTC Fact Sheet for Commercialized Granite Kernel. PTC Fact Sheet for Commercialized Granite Kernel. In 2014, PTC started to market APIs for their proprietary geometry engine, giving it a name for the first time, Granite. They had hoped to create an ecosystem of Creo apps, but they found that it generated little interest on a market more geared towards interoperability. PTC continues to develop Granite in its Creo products and still allows customers to leverage their APIs to build Creo apps. More on this later in the article. Siemens decides to commercialize Parasolid. Unigraphics before the transformation to NX. Unigraphics before the transformation to NX. By stark contrast, EDS Unigraphics, and later EDS PLM, UGS, Siemens PLM, and Siemens Digital Industries Software, in its various forms and corporate changes, kept to a consistently open framework. Tony Effuso, CEO of this group for over 30 years, told me, "We had a strong belief in our culture that the rich data that customers created with CAD/CAM/CAE, C3 products needed to be shared among many users across their company. If data sharing was successful, it would be extremely valuable to all customers in our industry and would enable the digital transformation of their products and their manufacturing processes." You may recall that one of the largest obstacles to data sharing was that C3 vendors all had different proprietary data formats, and it was very difficult, not to say occasionally impossible, to convert them into a usable format while maintaining data integrity and modeling history. To help facilitate data sharing between C3 software applications in the 90s, we created the Toolkit Group, whose mission was to build the level playing field for all of the licensees of our Parasolid kernel, and later, the other key kernels from D-Cubed, Parametric Constraints, and Vistagy, Composites Modeling. The Toolkit Group was run as a separate business unit, now called Siemens PLM Components, that worked with all of our competitors using our kernels to ensure equal treatment in kernel technology upgrades and licensing schemes. Our belief was that the kernels were more of a commodity and that the competitive differentiation for software app developers was really the application on top of the kernels. As time has gone by, the teams and management involved with running the level playing field at UGS and later Siemens have licensed these toolkits to well over 200 software vendors and have achieved remarkable results in enabling the rich data sharing for C3 customers across the globe. This was really a turning point in the industry, and we will see later that there are still many competitors to Siemens CAD products using Parasolid. Internally, the flagship CAD of Siemens, formerly called Unigraphics, now called NX, uses Parasolid. Shapr 3D on iPad. Shapr 3D on iPad. In 2015, CAD expert Istvan Sanity realized the power of the newly introduced Apple iPad and decided to create the world's first CAD app native to iOS, baptizing it Shapr 3D for his eponymous company. As to why he pivoted from the open-source Open Cascade kernel from Capgemini Engineering, see chapter below, to the Parasolid kernel, Istvan told me this. "It's simply the most robust and fastest kernel on the market, also basically the industry standard, as NX, SolidWorks are based on it, covering a very large chunk of the market. And it is the only industrial-grade kernel that's available on Windows, Mac, iOS, and VisionOS." Istvan mentions VisionOS because they also were the first app demoed on the Vision Pro during the official Apple announcement at WWDC 2023. Their focus is industrial design and they are based in Budapest, Hungary. The histories of CGM and ASUS via CATIA and Spatial. CATIA v5. CATIA v5. In contrast, Dassault Systems developed the CATIA Geometric Modeler (CGM) specifically for its CATIA software, with CGM becoming the core kernel starting with CATIA v5 in 1999 and continuing through to the 3D Experience platform. Earlier versions, CATIA v1 through v4, relied on different surface modeling technologies, with v4 using a proprietary kernel whereas CGM was built explicitly for CATIA v5. I asked Alan Dugasset, CATIA Top Gun and enthusiast, to explain this to me. On CATIA v3, our kernel was a solid modeler, solid M, with some Boolean operations between them. With v4, rather than just facets, red triangles, the surfaces became mathematical surfaces with a first pass at exact surfaces, red NURBS support, thus it was called solid E. There were some initial experiments in parametric modeling because of the pressure from PTC's explosive growth of Pro/Engineer. It was decided that a new architecture was necessary for the next generation, Next, and so they created the CATIA Graphic Modeler for CATIA v5, which was the world's first graphics engine that incorporated direct modeling, exact surface modeling, and parametric modeling in the same kernel. It has continued to improve for very small assemblies, watch mechanisms, and very large assembles, buildings, bridges, and cities, as it evolved to CATIA v6 and the latest incarnation, CATIA 3D Experience. It is a dominant player in mechanical industries such as aerospace, automotive, and industrial equipment. It's my favorite CAD package, can you tell? CATIA v5 marked a complete break from its predecessor, not just in interface or architecture, but in philosophy. Where v4 had been tailored largely to Boeing's stringent surface modeling needs, v5 was a true blank page initiative, reimagined in C++ and built to be more accessible, with usability lessons drawn from SolidWorks as well as the previous experiments in SolidM and SolidE, and a deliberate effort to avoid the perceived complexity of Pro/Engineer. As Didier Barquier, the lead developer of CATIA v5, explained, "With CATIA v5, we didn't just update the old system, we started from scratch. The move from Fortran we used in v4 to C++, the replacement of the legacy geometric modeler, and a complete rethink of the system architecture were all necessary to meet the demands of modern engineering and embrace the rise of Windows workstations. Even the constraint solver, initially D-cubed, was replaced with a custom-built engine we fully owned. The real driving force behind v5's evolution was Toyota, whose deep expertise in surface modeling, user workflows, and design change stability pushed Dassault to rethink everything from topological tracking to modification robustness as well as ease of use. The early CGM kernel, initially prone to cascading failures from small edge modifications, matured into a topology-aware modeler under the guidance of both internal champions like Didier Barquier, quoted just above, and relentless customer pressure. As Jacques-Livien Iserols, former CEO of CATIA, put it, "The CGM kernel wasn't just engineered, it was shaped by the hands of our clients. Toyota, Boeing, Honda, they didn't just push for features, they pushed us to rethink robustness, surface control, and the very complex relationship between user and geometry. Without them, CATIA wouldn't be what it is today." Thousands of evolution requests from Toyota alone shaped v5 and v6 over multiple versions. Dassault's future, it became clear, would depend not just on innovation, but on deep, sustained collaboration with the world's most exacting manufacturers. CATIA v6. CATIA v6. In 2008, DS made the revolutionary decision to break the file-based paradigm and store all CATIA v6 data in the Innovia v6 database instead. Needless to say, users were a bit surprised to lose the file open menu item. However, the idea of storing the CAD data in a database was not new. There had been several attempts to do this using Oracle blobs, but they were typically performance catastrophes. Notably, Innovia v5 managed CAD data in the database with a black box option to use a file system which became popular. Nonetheless, CATIA v5 is most commonly used with CATPart files, whereas CATIA v6 and CATIA 3D Experience no longer offer a file-based option. Staubli Robot Studio. Staubli Robot Studio. By 2011, Dassault's subsidiary, Spatial Technologies, acquired by DS in 2000, began selling CGM as a standalone component to Mitsui Zosen Systems Research Incorporated, MSR. As recently as 2022, it was adopted by robotic firm Staubli for its robotics suite, leveraging CGM's compatibility with CATIA v5 and CATIA 3D Experience. BricsCAD Screenshot. BricsCAD Screenshot. After the acquisition of Spatial, Dassault cleaned up ASUS, fixing memory leaks and expanding functionality. But ASUS, once poised to challenge Parasolid, never regained the momentum it lost after both SolidWorks and Autodesk abandoned it. Those stories coming up soon. While Spatial continues to license ASUS widely in mid-tier applications like Dassault Systèmes DraftSight, BricsCAD, and IronCAD, albeit in this case with a Parasolid dual kernel, as well as a handful of various CAM and CMM software vendors, the kernel now sits behind the scenes, powering tools in markets where cost or compatibility matter more than cutting-edge modeling. Siemens PLM components versus Spatial face-off. Now that we have seen the history of the graphics kernels commercialized by both Spatial, DS, and Siemens PLM components, here is a handy comparison table of their offerings off of their respective websites. Face-off between Siemens PLM components and Spatial. Face-off between Siemens PLM components and Spatial. Notes: / the NX Open API is not sold by Siemens PLM components, but is a development kit similar to what we saw for Granite, so customers can build apps on top of NX**. / Vistagy FiberSim is sold by the Specialized Engineering Solutions Group and not by Siemens PLM components. Interestingly enough, other than the final two categories, for which Dassault has solutions in NetVibes/Innovia and Delmia respectively, just not externally licensed, the two companies stack up rather well. I find it surprising that 3D XML, which DS has been promoting as a 3D experience exchange format, doesn't show up here. In terms of overall market penetration, you'll have to read on, no spoilers. Besides all of these proprietary kernels we have discussed, there is one open source project out there with a fascinating story. That's up next. The open source kernel, Open Cascade's fascinating history, origins and development. Euclid.cas.cade. Euclid.cas.cade. The CAD package Euclid was initially developed in the early 1970s by Jean-Marc Brun and Michel Ferrin at the Laboratoire d'Informatique pour la Mécanique et les Sciences de l'Ingénieur, LIMSI, in France, focusing on modeling fluid flow. In 1979, they founded DataVision to commercialize their work, which was subsequently acquired by Matra, forming Matra DataVision in 1980. Throughout the 1980s and 1990s, Matra DataVision developed the Euclid.as solid modeling 3D CAD software, notable for its hybrid modeling approach combining boundary representation, BREP, and constructive solid geometry, CSG, techniques. Evolution and open sourcing. The original Euclid Quantum CD4, Silicon Graphics. The original Euclid Quantum CD4, Silicon Graphics. In 1997, Matra DataVision introduced Euclid Quantum, a new generation of their CAD system built on the CAS.cade, computer-aided software for computer-aided design and engineering, platform. By 1999, Matra DataVision transitioned CAS.cade to open source, releasing it as Open Cascade, which later became known as Open Cascade Technology. Acquisition and legacy. History of MDTV in Open Cascade. History of MDTV in Open Cascade. In 1998, Dassault Systèmes acquired Matra DataVision, but stopped developing Euclid, since it was redundant with the shortly to be released CATIA V5, although Euclid Styler and Euclid Machinist survived in the CATIA V5 universe for a few years until DS had absorbed the technology they could salvage from them into CATIA V5 and Delmia V5. Today, Open Cascade technology continues to be a foundational platform for various low-end CAD applications, maintained by Open Cascade Technologies, OCCT, a subsidiary of Capgemini Engineering acquired in 2014 at the end of a long series of acquisitions. You'll see Open Cascade pop up again in this story a little later.